Okay, so after learning about what radians are and getting a little bit used to converting them, now we're going to use them to do the kinds of things we did last year in grade 11 with degrees. So I would imagine for a lot of us, we're thinking in degrees and constantly converting to radians to answer the questions, but we're kind of going back and forth. It's like when I don't know if you've ever heard this, but when you learn a new language, you really are, like you would be thinking your native language, let's say it's English, you would be thinking that way in your head and translating to your new language like French or whatever constantly. And when somebody speaks to you, you think about what that means in English, you think about your response in English, translate it, and then give your response. And then as you become more fluent, you actually think and just naturally converse without doing the translation in the new language. And that's when you become fluent. The same would be for things in math like this. At first, when you're not used to it, you're probably always kind of converting. Okay, pi by 4, that's like a 45 degrees. So then if I have 3 of those, where does that? Like you're probably kind of always doing that. And that's okay. I think that's normal. That's part of it. It's good to be aware that that's what you're doing. But eventually, you might find all of a sudden you're thinking in radians. And you just kind of do it. You just kind of know it in radians as well as you know in degrees. That's what you'd be aiming for. Okay? If we did this for long enough, eventually that's what you'd be aiming for. But if you're not there yet, and while we're solving problems with radians, you're still in the process of kind of converting, then that's okay too. But you don't want to, but like we're doing all the work in radians, and we're showing all the work in radians. We're not converting, solving, and then reconverting, not what we're doing, right? Okay, all that being said, let's take a look at the special triangles. So one of the special triangles that comes from an equilateral triangle has a right angle in it, and a right angle is pi by 2. See, again, you're like, okay, and then, yeah, this is the one that's got a 60 degree and a 30 degree. What are those in radians? See how we automatically go to, I think, the degrees and then convert. But this one's pi by 3, and this one's pi by 6. Don't write this in. You can just watch me do it. Don't write this in because it'll clutter things up. But this is like 3 pi by 6, and this is like 2 pi by 3. Sorry, by 6, not by 3. 2 pi by 6. 2 pi by 6 plus 3 pi by 6 plus 1 pi by 6 gives you pi, right? 6 pi by 6, that's pi, which is 180 degrees, so that makes sense for a triangle. So because the denominators are different, you don't see it. But again, that's a nice connection to make thinking, I think, thinking about how, like, what they are in radians, and making those connections in radians will help you get used to working that way. Okay, and our side lengths are 1, 2, and root 3. Okay, then our isosceles triangle, which has pi by 4 and pi by 4, two 45-degree angles, and then pi by 2, which is our right angle again. And that's 1, 1, and root 2. And that one you can probably see a little bit better. Pi by 4 plus pi by 2. That's like a quarter and a half. That's a whole pi. A whole pi is 180 degrees, so that's a triangle. Perfect. All right. We're going to use these to answer some questions. And the first questions, determine the exact value of each of the following. We're going to try to do this without converting it to degrees. But if that's what you do, that's okay. Four pi by 3 is a little bit more than 3 pi by 3, which is a whole pi, which is a half a circle. So it's 3 pi by 3 plus another pi by 3. Is that good? Does that make sense? So we're in quadrant 3 here. I've got to come up with my related angle. It sounds, I've gathered that you call that beta. Is that what you called it last year? Yeah, I don't call it that, so you can call it beta if you want. I'll know what that means, but I call it theta related, as I'm sure you've gathered. So it's a related angle, okay? And it's that guy right there, right? So in this case, theta related is the 3 pi by 3 plus an extra pi by 3, because it's 3 pi by 3 plus one more gives you the 4 pi by 3, right? So that's pi by 3. You don't necessarily have to write that down because this is how we're going to show our work. This is negative because it's in the third quadrant and cosine is negative there. The cosine of the related angle. And I'm going to use special triangles to figure out what the cosine of pi by 3 is. So cosine is adjacent, right? Here's my angle. So adjacent over hypotenuse, which is 1 over 2. So this is negative 1/2. And if your calculator's in radians, you could check that. Cos bracket 4 pi divided by 3 equals, and it'll give you negative 1/2 or negative 0.5. Remember, cos pi by 3 was that check that we talked about yesterday, because that's like 60 degrees. Cos of 60 is a half. Cos of pi by 3 is a half. That's a good check to make sure your calculator is in the right mode. Any questions about that? Lots of little things. Cast rule to determine if it's positive or negative. We have to know what quadrant it's in so that I can figure out the related angle, so that I can figure out which of the special triangles, or, you know, if it wasn't a special triangle, still I'd have to figure out what the related angle is to work all of that out. Sure, that one you can answer with your calculator, but you have to show your work. So you would have to write this step for full marks, because we're not just trying to get the answer, we're trying to understand this. Okay, cotangent of 3 pi by 4. What quadrant are we in here? So we're in pi by 2 is this one, right? That's pi by 2. This is pi. So 3 pi by 4, that's like 75% of it. So you're 3/4 of the way there. You're more than halfway there. So I'm in this quadrant. And again, I'm 1 pi by 4 back from full pi, right? So this is my related angle. And I go all the way around to pi. And then I back off, which would be like 4 pi by 4, back off by 1 pi by 4. Probably another reason why this stuff is hard is if you don't quite see the connections with the fractions, if that's tricky, that does make it harder. Okay, so this is, we're in the second quadrant, so cotangent is negative in the second quadrant. So it's negative cotangent of pi by 4, but my calculator doesn't have cotangent button. So it's negative 1 over the tan of pi by 4. You don't have to show both those steps. But is everybody okay with that? What is the tan of pi by 4? 1 over 1, which is 1. So this is negative 1 over 1, which is just negative 1. Again, you could punch that one in your calculator and it would give you a very clear answer. And I mean, I would use my calculator to check these, right? Like I'd show my work because that's how you get full marks, but then I would absolutely be putting that into my calculator. And I would put this, like tan of 3 pi by 4. And then either do 1 over, or if you can just do that part in your head, whatever it is, right? Gives you -1. Okay, one more. Any questions so far? Very good. Following along okay? One more. Why don't you see if you can draw this diagram yourself? So 7 pi by 6 is like pi by 6, or sorry, 6 pi by 6, which is a full half circle, right? A full, like one halfway around, plus another little bit more. So plus another pi by 6. 6 pi by 6 plus 1 pi by 6. So theta related is pi by 6. Cosecant is the reciprocal of sine. So this is 1 over sine. Sine is negative, so this is -1 over sine of pi by 6. Okay, and see if you can use special triangles to figure that guy out. So what's this? Can somebody tell me what the sine of pi by 6 is? Kyle? Yeah, 1 over 2. Opposite over hypotenuse. So this is like -1 over 1 over 2, which is -2. Good? Questions? Okay, example 2, this is kind of like going the other direction. We give you the answer, you got to come up with theta. But for each of the original trig ratios and each of the reciprocal ratios, they're positive in 2 quadrants and negative in 2 quadrants, right? So, I have to look at the domain that it's asking me to solve this in, 0 less than or equal to theta less than or equal to 2 pi. That's what tells me this should be answered in radians. If that said less than or equal to 360 degrees, then you could answer in degrees, right? So when it gives you that domain, it's telling you how you should answer. One thing to be mindful of. So in other words, this is going to give me, each of these is going to give me 2 possible answers. So first we find theta related, then we figure out which quadrants it would be in, and then we write our 2 answers. All right, so let's get started. So for this first one, cast says sine is negative. The answer is negative. It gives me that, right? It says negative 1 over root 2. So the answer is negative. So I'm looking for the quadrants where sine is negative. So that's here. But I don't know which. It's negative in both. There's a possible radian value that will give me this answer, negative 1 over root 2 sine of theta, whatever theta is. There's two possibilities between 0 and 2 pi that will give me that answer. Okay, so the first thing we're going to come up with is theta related, which in other words, again, using special triangles, 1 over root 2, there, it's that triangle. And sine is opposite over hypotenuse, so opposite over hypotenuse, 1 over root 2, pi by 4. So theta in quadrant 3 is pi plus pi by 4, and theta in quadrant 4 is 2 pi minus pi by 4. Pi plus pi by 4 is 4 by pi by 4 plus another 1 pi by 4, so 5 pi by 4. And then the next one would be like 8 pi over 4, right? Twice as much on top. Give me 2, so 8 pi by 4 minus 1 pi by 4, 7 pi by 4. Okay, try the next one. At least get it started. Who knows what the related angle is? Yeah. Pi over 6? How'd you get pi over 6? Yeah. Good. So, wait, so pi over 3? Okay. Are you sure of that one? Which one? Now, whenever we answer 2, it's always like, well, wait a minute, because I thought it was that and it was that. What do you think? Kyle, what do you think? You agree with pi over 3? Okay. Yeah, I think that's right. Very good. And tan is positive in quadrant 1 and quadrant 3. So theta in quadrant 1 just equals pi over 3, same as the related angle. And theta in quadrant 3 is 3 pi by 3 plus another 1 pi by 3. So 4 pi by 3. Okay, good. One more. It's a little bit different. And sine and cosine in this case are like how you would approach these are different from tan. Cosine theta equals negative 1. does it mean for cosine theta equal -1? Okay, so here's my related angle. This blue one. Cosine is adjacent, or x, right? So kicks or ticks. Cosine is x over r. So if this is my angle, it's x over r, or it's adjacent over hypotenuse. When will that equal 1? That ratio of adjacent to hypotenuse, when will it equal 1? When x and r are the same, or when adjacent and hypotenuse are the same, which is not a triangle, right? You can't have two side lengths the same in that situation, the same as the hypotenuse. You can't have one the same as the hypotenuse. Obviously, isosceles triangles have two the same. When are they the same? Right? There we go. So watch this. As I get closer to the x-axis with my point, the radial arm, the radius here, is getting closer, is a little bit longer, but it's getting smaller and is getting closer and closer and closer to the same length as x. And my y, or my opposite, is getting closer and closer to 0. And there we go. Now they're the same. And the sign here would be 0 over 1. So the sign would be 0, but cosine would be 1. But we don't want 1, we want -1. So where does that occur? Well, when x is negative, but x and r are otherwise the same. So right there. And so what's the value in radians of this actual angle at that point? Like in this case, we don't really worry about cast and such as much. We don't really do it that way. We just realize that it occurs here. And we only have one answer, and it's pi. So it's a special case. We do it differently. You want to recognize that. For cosine and sine, whenever they're 1 or -1, that's what we do. But tan's different because tan is opposite over adjacent. When does that happen? That happens in that triangle. All right, one word problem. I'm not sure you have to write the whole thing down. In fact, if you want to just watch, you can do that and you can copy it down later or just reference it if you have to. Because the half of this is just a blurb about a compass. The compass, like that measure, is not the one that we use, not a set of compasses that we use to draw circles. A compass that measures direction relative to magnetic north is typically broken up into 4 quadrants, just like our Cartesian plane, although where it starts and counts from 0 degrees is different. That's not going to matter for us because we're not doing that. But that's called like if you talk about bearing or true bearing, if you're navigating, your 0 degrees would be different from what it is on the Cartesian plane, right? But anyway, it's besides the point. So sometimes those quadrants are divided up in other ways too. Like you can have northeast, you can have north-northeast or northeast-east. Like you can divide it up into all different kinds of ways. And there's a big, and if anybody's done any kind of geography, then you know more about this than I do, but there's all kinds of standards about how you measure angles when you're navigating this way, right? Which obviously, so that everybody is speaking the same language when they're out there. Okay, so in this case, we've broken this up into 1, 2, 3, 4, 5, 6, 7, 8 relevant sections. I'm kind of problem solving here. There's sort of 3 application questions that you can try in the practice, and each one of them is a little bit, one's a lot like this, but the other ones are a little bit different. But in every case, I think it helps to think about like the circle and how it's being divided up. How many pieces, and how does that relate to the radians that we've been doing, right? Okay, so we're going to draw this. I'm going to do a let statement, so I'm going to leave some room for that, but I'm going to draw this as well. Because this is where it gets, I have to understand what it's talking about. The needle is pointing directly southwest. So that's where the needle is pointing. And the tip of the needle is directly below a point that is 3 centimeters from the center along the western axis. So if that, whoops, that was terrible. If this is west, then this is my 3 centimeters. Okay, the tip of the needle is directly below a point that is 3 centimeters from the center along the western axis, which makes sense if it's pointing directly southwest. How long is the needle? So there's my x. So let x represent the length of the needle. Typically in these trig questions where you first of all, draw it is always a good idea. Like absolutely 100%. These would be hard unless you were a very visual person and can visualize things in your head. Maybe you can, but like I find that really hard. So drawing it is the first trick. I always remember in grade 10, people who are resistant to draw it, and they're sitting there trying to do word problem. They're like, I can't figure it out. I can't figure it out. I don't know what to do. I say, well, you haven't drawn it. Draw it. Oh, okay, now I know what to do, right? So really, really strong recommendation to always draw it. And if you draw it and label it with an X, you don't technically need a let statement in these cases for me, but it's not a bad idea in this case. Okay, so X is the length of the needle. I can find this angle, which you probably kind of can just intuitively figure out what that is, but I'm going to talk it through a little bit more as well. That'll be helpful for other applications, okay? And then I can just solve it, okay, with like an old school trig formula. So I've broken this up into 1, 2, 3, 4, 5, 6, 7, 8 pieces, okay? And a full circle is 2 pi, but I've divided it by 8. They're equal segments, so each one of those segments is pi by 4. Does that make sense? I think this is always a good way of thinking about it. What's a full circle? It's 2 pi. How many equal segments have you divided it up into? I'm thinking like a clock. You could divide it into 12 equal segments, or you could divide it into 60 equal segments, or you could divide it in lots of other ways, in 10-minute intervals and 20-minute intervals, right? You could all those ways. So how many equal intervals are you splitting it up into? Okay, so I've got pi plus another pi by 4, or I can think about just this one segment, because it's from like here to here, is one of those segments. So this is pi by 4. A lot of you are probably already thinking it's 45 degrees. If it's 45, then it's 90, and like it's pretty obvious. But it might be obvious in this case. Wouldn't necessarily always be that way. So this is now kind of like a grade 10 question, except we're using radians. So when I look at this, I've got my hypotenuse is x. Opposite is this side that I don't care about. Right? This side is opposite. This is my adjacent. So I'm talking cosine here. So therefore, cosine theta is adjacent. I write down my formula over hypotenuse. Cosine of pi by 4 is equal to adjacent, which is 3, over my hypotenuse, which is x. Now this is cool. I like this. There's 2 ways that we can solve this. We can solve it the old school way, which would look like this. This is how I do it. I always think about like, there's sort of 3 different types. You're looking for an angle. This isn't that type. It's not theta. We know the angle. Or you have x on top, or you have x on bottom. This is the x on bottom type. So the x on bottom type looks like this. The x and the cos part trade places. So I've got this solved for x, and I just punch in 3 divided by cos of pi by 4 in radians. Make sure I'm in radians. I just type that into my calculator. That's one way that I can do it. Give that a try. See what you get. Somebody tell me what they get. Caleb, what you get? Nice. Anybody else confirm that? 4.24. What are we talking here? Centimeters? Anybody else get that? Yeah? Good. What's the other way we can do it? Special triangles. I mean, it's 45 degrees. It's pi by 4. That's an easy one. So if I go back up to my special triangles, the cos of pi by 4 is 1 over root 2. Right? So, how do I use that here? I replace cos of pi by 4 with 1 over root 2 equals 3 over x, and x equals 3 root 2. Do that on your calculator, 3 root 2. Ross, what'd you get? 4.24. Awesome. Therefore, the needle is 4.24 centimeters long. Fantastic. Any questions?